So let's move on to the second use case where we are also using this in biomedical domain. So we are essentially now again dealing with three-dimensional data rather than images, and we are using convolutional neural networks type of architecture to recognize certain features. Okay, so what is the problem that we are working right now? So this is we have been collaborating with faculty in medical school at UB, and we are essentially focused on what is known as identifying these bulges, which are known as aneurysms. So this is typically in the brain vessels. You might get this cerebral aneurysm, and they have high probability, some probability of rupturing. And so what you want to do is you want to quickly identify, given the brain scans, whether you have this aneurysm or not, and hopefully you quantify some of the properties of this aneurysm, and that might be helpful in sort of dealing with this aneurysm in a given patient. So you can use this as a basis to prescribe what should be done with the specific case we have, right? Again, the rupture risk is low, typically 1.4% 1 year, 3.4% in 5 years, that is there. And then there are typical treatments that you can have. You can have endovascular or surgical processes. So based upon what you have identified and what is there in the image that you have scanned, that you got after scanning a patient, you want to possibly decide on what possible treatment option that you are going to be taking. Okay, so again, for many clinicians, the dilemma is whether or not to treat this, right? Sometimes they decide not to treat it and say that, okay, looking at what we have here, it's not going to rupture, and we should not worry too much about it. And then they call the patient and do repetitive, basically scanning. And when they identify that no longer going forward, I think we have to do one of this treatment, then they go for it, right? So this type of decisions are essentially made, but those decisions are based upon essentially different morphological parameters of this aneurysm. Okay. So what we are going to do is we are going to take an image, and we are basically going to extract this feature, and we are going to automatically calculate these parameters, which are like the neck diameter, the dome height, and so on, which are the morphological parameters related to aneurysm, and that helps us in the decision making whether we should leave it and not do anything, or whether we should go for the treatment option A, or whether we should go for treatment option B, and so on. Okay, so this detecting the aneurysm in the brain vessels and then automatically computing this neck diameter and dome height is the main problem that is there that we have worked on, right? So here you can see there we have a computational pipeline which also focuses on geometry. So we have a geometrical pipeline that helps us in basically taking the overall image and focusing on and identifying this, the red blob that you see at the final portion, which is essentially the aneurysm that is out there. Okay, and how do we do that? We basically use a convolutional neural network to identify the neck portion in the overall pipeline that we have. And once we identify the neck portion, we can basically cut and get the 3D model or the portion that is just focused on the aneurysm portion, and from there we can compute the morphological properties like what is the bulge diameter and so on, and that helps us in the treatment planning purposes. So this is an example where a lot of convolutional neural networks are being currently used in biomedical domain for image processing that is coming from doctors and so on. Okay. So here is another example that I want to quickly show you where we have where medical image analysis is essentially carried out by convolutional neural network. So this is an example where this is known as Eyes of Watson. So this is an IBM based CNN medical image analysis tools that they are doing, and in this they basically identify different types of features, different types of properties of the images that helps us in the treatment planning. And this is a general purpose software that is used where they are essentially focusing on a wide variety of different images, a different class of medical diagnosis application, and for different cases they have created and customized different types of CNN and different types of diseases they have been able to solve and do the diagnostics. So this is another example where the CNN is being used for medical image analysis processes.